Okay, for this review problem, we're going to show that if n is an integer, then 3 is not a factor of 3n plus 2. This one can be done by contrapositive, but instead I will do this one by contradiction. And so for proof by contradiction, let n be an integer. And suppose that the negation of the conclusion is true. Suppose, for the sake of contradiction, that 3 is a factor of 3n plus 2. Suppose that were to happen. Now I'm going to assume the hypothesis, I will assume the negation of the conclusion, and I will show that's impossible, that something unusual happens when I come out the other end. So by definition, there is an integer k, so that 3n plus 2 is equal to 3k. So if 3 divides 3n plus 2, that means 3n plus 2 is equal to 3 times some integer. So that, well, let's see, that means I can write 2 is equal to 3 times k minus 3 times n, getting the 2 by itself. Or I factor the 3 out, that 2 is equal to 3 times k minus n. All right, now the thing in parentheses is an integer. N is an integer, k is an integer. So by the axioms of arithmetic, k minus n is an integer. If I subtract two integers, the result is an integer. So 3 times an integer is equal to 2, and therefore 3 divides 2 by definition. Well, that's not right, but we know that 3 is not a factor of 2. And so that's our contradiction. And so I put my contradiction symbol, 3 divides 2, but we know full well that's false. So that's my contradiction. Now what did I contradict? I supposed that 3 divided 3n plus 2, that's false, and so I conclude, therefore, that 3 does not divide 3n plus 2, and that's the end of the proof. Okay, so once again, for a proof by contradiction, we assume the hypothesis, we assume the negation of the conclusion, and somehow come out the other end with a ridiculous statement. That's the non-technical term for it. So come up with something that is patently false. In this case, the thing that's patently false was that 3 is a factor of 2. So that's false, and so I know that the original conclusion has to be correct.